So let's talk about functional programming. So functional programming is a style of programming where the idea is that everything is a function and everything is a so-called pure function. And a pure function is a function that does not mutate the world around it. And that means basically that you can use it in any context without it breaking or doing something that it's not supposed to be doing, or in any case doesn't mutate anything. So to kind of illustrate this, here's an impure function. And the reason why this is an impure function is that we are getting an object and we are putting a property called foo on it, and we're setting that to a value, and then we're returning that object. This is an impure action because now we have mutated whatever my object is. So what happens if we call this function and then some other code that we have expects this to not have the foo property? Then our code will break because we mutated the original object. But in functional programming, that's not allowed. So if you wanted to do this in a pure way or a functional way, you would copy the original object. So this is what's happening here. Object.assign. So we take an empty object and we copy everything on my object over to that object, and here's our copy. And on the copy we set the property foo, and then we return the copy. This leaves the original object intact, we haven't changed it, and we still get the same results. So this is what purity means. Nothing changed, we're just returning a copy. Okay, so let's talk a little bit about impurities. So another example of impurities is that you can do something that changes the state of the world or has a dependency on something in the context of the code that you're running. So that is impurity, because you are not allowed to create in functional programming to create a function that has a dependency or hasn't, that where you take away the control from the caller to decide how a certain piece of code is going to work. So to illustrate this, we have an impure function, and this is an impure function because it does a AJAX call to some resource, and then it basically gets that resource and returns a string of some sort. And the reason why this is impure is because now we assume that fetch is going to be in the browser, and that's a problem because not all browsers have fetch, and you might not actually know whether or not this fetch function is the function that you're expecting because you're making this global reference. And what's even worse is that fetch returns a promise, which is not a synchronous operation, which means that now this function is going to have a very specific behavior that the rest of your code needs to take into account in order to work. So this makes this an impure function. However, if we wanted to do this in a pure way, let's say that we actually give it the fetch function and then we call it in the same way. Now that means that fetch can be anything. We are taking the responsibility and giving that to the caller, so whoever's calling this function is now in charge of making sure that the fetch function does what it's supposed to be doing. And we remove the global thing, which means that let's say that the browser that we're using doesn't have fetch and we're using some other function that is going to do the same thing. Well, then we can pass that function in, and that makes this a pure function because now this function is unaware of the state of the world. Its only context is this function that it's given, and this makes this extremely testable in addition to being very flexible. So in functional programming there is a term called higher order function, and that's a fancy name for a function that either takes or returns another function. And here we have an example of one such function. A classic example I see a lot is when people want to use one of the array functions such as map or for each or filter. And what often happens, I see people do this all the time, they will use an anonymous function and then they will often use the exact same logic over and over, or something that is very similar to the logic, which is usually to look at a property or look for some value or do something to that value. And if you're using a higher order function, you can actually make this look a bit nicer. So here we have a function that's called add. it takes a number, but it returns a function. And that function takes a value, and then it adds these two together. So what we can then do is to look at map and say, well, we have this array and we want to add a certain number to it, and then we just call the add function with the number that we wanted to use. So this will now return a new function that does the exact thing we want. It's going to add all these numbers with the number 1. And this gets really flexible, as you can see, because now we can add a 2 and we can just do any number. And this makes this is in essence what a higher order function does. It can either take a function or return another function. And if you think about it, well, map is a higher order function because it takes a function that decides what map is going to do on each element it passes through. And then the other higher order function is add because it returns a function that we can so-called pre-program to have a certain behavior. Okay, so let's talk a little bit about predictable values in functional programming. So what a predictable value and what the idea behind that is basically the concept that for every given input there should be one and the same output. So if you wanted to make sure that you have a pure function and a predictable value, you would check, okay, for this one input, do I have the same output? And it can never mutate the global state or the world around it. It is not allowed to reach outside of its own context. And if we look at this impure divide function, we're checking if A or B is equal to 0, and if they are, we throw an error. That's wrong right away, because in functional programming you're not allowed to break your code. You're not allowed to mutate anything outside of the function. So this is not okay. So if we wanted to make this a little bit more functional, we would take the same input and then we would check, okay, is A equal to a number and is B equal to a number? Because if they both are, then we can make a nice evaluation here. So we check, are both a number and are they equal to 0? Are any of them equal to 0? Then we return -1 instead of throwing the error, because we are now making sure that we communicate to the caller that, well, this is not correct. We got some unusable input here, but instead of throwing an error and breaking the code, we just return a -1 that communicates that something went wrong, right? And then we run the function as previously. And this change might seem subtle, but it's very nice in the terms that this way of programming makes your code very robust. It doesn't just throw an error and break your whole application. So even if your function might be misbehaving, the rest of the code will still work.